All right, this lesson we are discussing rational numbers. And in the definition, what did the definition tell you?
It's a number that can be written as a fraction where A and B are integers and B is
A simpler definition is a number that can be written as the ratio of two integers. Okay, so they give you a nifty little chart here. Rational numbers, and you see they have some symbols. Let me grab my little... See how this has a little line over the two?
Yes.
What does that little line mean?
It means like it's terminating.
It's a repeating decimal. It means that 2 goes on forever. They're just not going to write it. So they put the line over it to terminate it, even though it's not a terminating decimal. It's a repeating decimal.
Is that why they put the 7 on calculators?
Yes, they usually just round it and stop it. But they still, most calculators have that little line that they put over the top of it. Okay, so a repeating decimal, is that a rational number? Yes, it's in the box of rational numbers. What about a terminating decimal, which you can...
It's a decimal that ends.
Yep, it is a decimal that has...
5.8.
Yep, 5.8 would be the terminating. Is that a rational number?
Yes.
Yes. Now, within rational numbers, you see we have what we call integers. An integer is a whole number that can be either positive or negative. Now, interestingly enough, integers cannot be 0. You see that? It has to.
0 is nothing.
0 is a whole number.
I have a question. So for the whole numbers, it says 0 and 4.
So it's positive whole numbers.
It doesn't mean just the whole numbers, it's just 0 and 4.
No, it's 0 and any number up there, 1, 2, 3, 4. It has to be a positive number, and it can't be a fraction, and 0 also counts.
So integers are not decimals?
Correct.
They're just
Or fractions. They're whole numbers, but they can be negative or positive.
Okay.
And it does not include. So this little chart is a really good chart to know. This is going to help you on your assignment today, okay? All right, so let's do some examples here on writing rational numbers as decimals. So we're going to be converting from fractions to decimals. Is that what I had y'all do yesterday?
But you had to simplify.
Simplify. Okay, I was warming you up.
It was
So this is example 1. Put this in your journals. We're going to write negative 2 1/4 as a decimal. Now the first thing we need to do is change this into improper. This is a mixed fraction.
4 times.
So to do that, I do, yes, you had it, 4 times 2 plus 1.
9.
So it gives you 9/4. Make sure you keep the negative on front. Once I have that as improper, to change it to a decimal, I just divide the bottom number into the top number. Now, if this is ever a 10 on the bottom, can you automatically know?
Yes.
Yes, because it's in the 10th place value. But we're going to divide. So we're going to divide 4 into 9.
So but does it, if it has a 10 on the bottom, does that mean it's a half? Like if it has like 5 over 10, that means it's a half?
Yes, because you can reduce it. It would be in a decimal, it'd be 0.05, not 0.01/2. Does that make sense? 0.05.
So whenever you simplify something, you know it's a half when it's just half of the bottom.
Yeah. Very quick. Yep. All right. So how many times can 4 go into 9?
0 to 0. 1, 2.
2. 4 times 2 is?
8.
How many times can 4 go into 10?
2.
How many times can 4 go into 20? Okay. And then you also need to throw the negative back in front. So negative 2.25 is our decimal. Now, those of you who like to do math in your head, let's look at this fraction one more time. We had negative 2 1/4. So you see how the negative 2 is still there, the whole number. When you think of 1 out of 4, think in quarters. If I had 4 quarters and I only have 1, how many?
25.
I have 25. So whenever you see it 1/4, 2/4, 3/4, that determines whether this is 25 cents, 50 cents, 75 cents. That's a quick way to think about it when you're dealing with quarters. 1/4. Okay? So little tricks. So for B, we're going to change 5/11 into a decimal. Do I need to adjust anything before I do my division? No. And in this case, it's over 11, so that's not a automatic know it. So let's divide. Can 11? So,
You always have to put the 2 zeros in the back.
I naturally do, because usually you have to go at least twice. You can do one, but almost always do you go twice. Can 11 go into 5?
No.
Can 11 go into 50?
Yes.
How many
Go in
times?
4 times.
Which is 44. Subtract and I get,
6.
bring down my 0. How many times can 11 go into 60?
55.
Very good.
5.
I knew what you meant. Then I get what?
5.
So bring down my 0. How many times can 11 go into 50?
4. It's just
It looks like it's going to be a repeat, but we need to check it one more time. So indeed, it is a repeating decimal. And it repeats at the 45. So I could have stopped after the first two if I had known it would be repeating. But when you answer it, you can answer it saying it is 0.45 repeating. Now that line is important.
that's the repeat.
It tells me that it's a repeating decimal, 4545 forever. If you don't have that on your answer, I will take off a half a point. Oh no, you can do it. All right, any questions on how to do this? All right, let's do some on your own. Grab your paper.
And you only put the line over the digits
That repeat. Yeah, so sometimes it's 2 digits that repeat forever. Sometimes it's just 1 digit that repeats forever. Good question. All right, so we're going to change -6/5 into a decimal.
So 5 by
5 into 6. It'd be 6 divided by 5 if you want to say that. So 5 goes into 6.
So the top number always goes in the.
No, the bottom number divides into the top number. So I always put the bottom number on the outside, the top number on the inside. How many times can 5 go into 6?
1,
How many times can 5 go into 10?
2.
Am I done?
Yes.
Yep. See, I put two zeros and I didn't need them. Now this was a negative number, so make sure you put a negative in front of that. All right, number 2, we have -7 and 3/8. What do I need to do first?
You need to multiply it. So 8 times 7.
Now, do you want me to show you the shortcut trick?
Yeah.
We know when you have a whole number in front like that, we know it's going to be 7 point something, right? Because it's a whole number. It's always going to have that whole number. So really all we need to figure out is this part of the decimal. So let's divide 8 into 3. How many times does 8 go into 3?
0.
8 into 30?
3 times.
8 times 3 is?
24.
It's 60. 8 goes into 60,
It goes in 7 times.
which is?
56.
So I get 40. 8 goes into 40.
5.
So then I just take this part of my decimal and I plug it in over here. So I get -7, whoops, 0.375 as my answer.
Mind blown.
Okay, so that's a shortcut when you're dealing with mixed numbers. You can just divide the fraction with the mixed number, but you have to remember to put that whole number in front.
The 40 on the bottom.
From divide.
6 minus 50, 60 minus 56 is 40. And then I ran out of space. Yeah. And I ran out of space, but I knew I was done, so. Okay, so if you can't, discipline yourself to remember that whole number in the front, then go the other way and make it an improper fraction and do the division the whole way, okay? But if you can remember that the whole number is just what's in front of the decimal, you can divide just the fraction. All right, number 3, we have -3/11. Didn't we just do that? Oh, we did 5/11. So we have 11 divided into 3. How many times can 11 go into 30?
It can go in 2 times.
Which is 8. 11 into 80.
7 times.
So 77. Oh, I'm guessing we're going to have a repeating. We are, aren't we? Because 30 is going to give me the same thing. So there's my answer. -0.27. Yeah, make sure you put the negative. Ooh, I would have lost a half a point on myself. And if it helps you, when you set up the division, just throw this negative up here. That way you don't forget it. All right, number 4. We have 1 and 5 over 27. So remember, we already know that it's going to be 1 point something, because the 1 is a whole number. So we're going to divide 27 into 5, and then we'll see how many of these zeros we need. 27 into 50 goes how many times?
1.
Which gives me
I'll give you 30.
23.
Uh-huh.
27 into 230. I can tell you it's going to be 8. What's 27 times 8?
What's the equation?
2 1s.
I was going to say, did you get 216? 27 into 5 point. So then I subtract, I get 14. 27 into 140. Try 5.
135.
And you notice my remainder is now what we started with, so this is repeating. So your answer is 1.185. That make sense?
Yep.
So when you get to the bottom and your remainder starts over with what you originally had, then you know it's going to be repeating after that. So you can just stop and put, oh, I need a line. I would have lost half a point. Call me out. Gary was trying to call me out, but I kept talking. Yeah. All right, any questions on those? All right, let's.
Was it a negative?
It was not. It was a positive 1 and 5 over 27. Okay, so now we're going to go from. I know, but it was originally a 1 and 527, so there was no negative with what I was saying. Yes, 185, because it starts over there. All right, so now we're going to go from decimal back to fractions. And this is actually slightly easier. Example 2, put this in your journals. All right, whisper. So we have negative 0.26. All you have to do for fraction is see how many place values you have here after the decimal. How many are there? So I'm going to say 26 over 1, and then however many place values, that's how many zeros.
Is it always 1?
Yes. Because decimals go by tens. Then your next step is to see if you can reduce that. So in this case, you can divide both by 2, and I get negative 13 over 50.
And 13 is a prime number.
Yep, so you know you're done. Very good. Okay, so first step, always just count how many place values there are and put it that many over 1 and the zeros of how many place values are. I said that horribly, but you understand what I'm saying, right?
Yeah.
Now, what if there is a whole number right here? What do you think I do?
Oh, you divide it.
No,
You would.
you would just make it a whole number.
Oh, 1, yes.
Okay? All right, so let's do on your own number 5. We're going to write negative 0.7 as a fraction. So how many place values are there?
1,
So I'm going to negative 7 over
10.
10. Can I reduce that at all?
No.
Nope.
Because 7 is a prime number.
7 is a prime number.
Wait, the whole fraction is a negative? Or just
The whole fraction's technically negative. He's asking, see how my negative looks like it's kind of hanging out with the 7? That's just because of how I wrote it. You could put it, you could put it right here. It would still be the same thing. All right, number 6, 8th grade. You are awfully noisy today.
Isn't it 125 and then over like...
So it'd be 125 over, that's right, put 3 zeros. Now can I reduce that?
No, 25.
By 25, for sure, yeah. So you divide both by 25, you get Divide the top by 25, you get 5.
So 5.
Yeah, he kept going. He got it. Yeah. 1 over 8 is the final answer, yeah. Yeah, you can actually divide 1,000 by 125. Mm-hmm. So 1 over 8 is the reduced form. Yes. Now you guys know in your calculators, if you just type the fraction and hit enter, it reduces it for you, right?
Yeah, I did.
I mind blown that yesterday. It was exciting. It's good for your brain to do this, guys. If it's something you can do, please do it. It's good for you. All right, number 7 on your own. Negative 3.1. So here we go. We're turning into a fraction. So we have 3 and 1 over what?
10.
And then what am I forgetting? There we go. We didn't have to reduce nothing. I like easy ones. Okay, so 10 is a whole number, so we're just going to put that in front of the fraction.
It's 25 over
100.
Now, can I reduce that?
Yes, 25. 1 over 2. No, 1 over
What are we,
4,
what are we
5, 4.
dividing it by?
Thinking money. I have 1 quarter on top, 4 quarters in the bottom.
So 1 over 4.
There you go.
I like money.
I do too. It's so much easier to deal with it. I wish everything was in quarters.
Is it possible to reduce the whole number?
Nope. Whole number will always be what it is. All right. One more example. Everybody got this? Turning the page here.
But one's a whole number and you can reduce it.
Yes. Well, but it's on top of a fraction. He's saying that 10 before it. That's just what it is. All right. So example 3. Big example? Kinda. I don't know if I'd call it big. Let me take a picture here. All right, so we have our little table here. Let me read to you. The table shows the elevations of 4 sea creatures relative to sea level. Which of the sea creatures are deeper than the whale? So since they're all mixed, they're all in fractions or decimals, we need them all to be the same.
Yes, you all.
So we can write them all as fractions or all as decimals. Now, which type of number is easier to put on a number line, a fraction or a decimal?
Decimal.
Decimals are easier. So since we're trying to figure out what's smaller to larger, I would change everything to a decimal. So let's look at anglerfish.
They already did, right?
Well, but you need to do it.
No.
That's just stepping. So anglerfish is negative 13 over 10. How do I make that a decimal? Divide 10 into 13. It's going to be negative what?
negative
10 into 13.
Goes 1.
negative 310.
10 goes into
33 times.
3 times. So negative 1.3. Right?
Yeah.
So anglerfish is negative 1.3. So now let's do the squid. So we already know it's negative 2 point something. So let's divide 5 into 1. That's an easy one. How many times does 5 go into 10?
2.
So it's going to be negative 2.2. Follow so far? If I'm going too fast, you just yell at me. Okay, the shark, we know it's a negative. 11 goes into 2. How many times can 11 go into 20? Just one time, right?
Yeah, 1 time.
Which gives us 9. How many times can 11 go into 90?
8.
Which is 88. So we get 2, and so we're repeating already. Negative 0.18. Okay, and then the last one's already done for us. Right? Okay, everybody got those in your journal?
No.
I will wait a second.
So I'm confused on the squid.
On the squid. We knew the 2 is a whole number, so I just went ahead and wrote negative 2, right?
The squid is in green.
No, the squid's in blue.
Oh yeah.
Shark's in green.
So 5.
So we divided 5 into 1, and that's where we got 0.2. So I put that after the whole number 2. So I got negative 2.2.
Negative.
Okay, it was a negative.
0.2.
Well, here it does. But over here where the answer is, I put negative 2.2. Because I knew the whole number was there. That's where I just skipped the whole number mess and just remembered it.
Okay, let me write down shark.
Yep.
Negative, right?
The shark is negative. All of them are negative. So next we're going to graph these on a number line. Okay, so I'm going to turn the page. You guys have all your measurements there. So you're going to graph these to find out. Yes, it's just a line. To find out the smallest to largest. Okay, everything's negative, so my zero's way over here, right?
2.2 is negative? Yes.
Yes, everything's negative. So, if I go by 4s, which is what they graphed it by. I'm going to run out of room. Okay, I'm just going to put way over here, negative 2.4. It doesn't have to be perfect. All right, so now let's graph on here. I'm going to get a bigger dot. Bam. What is my shark at?
Your shark is at
It is negative 0.18, so it's going to be somewhere right in there. Right? So negative 0.18, shark. Right?
Big or small?
So he's the biggest, well, he's the closest to 0. So he's the closest to sea level. So he swims near the top of the ocean. Because remember, 0 is sea level. We're seeing how deep these animals swim. Not compared to these other animals. All right, what's the next biggest one? So the whale's at negative 0.8. So this is negative 0.8 whale. Okay, what's our next one?
anglerfish.
He's at negative 1.3, so somewhere right in here. Negative 1.3, angler. Have you seen the anglerfish?
Yes, I agree.
That's that one on Finding Nemo with the ball hanging off his thing. Where he goes, ah, it scares everybody. Angler. Angler is, I don't know why they called him an anglerfish. Probably because it looks like he's baiting something. Yeah, that was the scariest part in Finding Nemo. And the squid is at what? Negative 2.2. Very good. Make sure you clean that off. Are you not graphing that in your journal?
Yeah, I want to write it.
Okay, just make sure you do. He just wanted to write on my table. Okay, so the question was, which of the sea creatures are deeper than the whale? So looking at the whale, which sea creatures swim deeper than the whale? Yep, so your answer is squid and anglerfish. So make sure, especially on word problems, you revisit what they're actually asking. Because in this case, I would have looked for the word squid and anglerfish. Is that surprising that there's things that swim deeper than a whale?
Yeah.
A little bit. All right, number 9 on your own. We're going to continue looking at this timeline or number line here. It says the elevation of a dolphin is negative 1/10 kilometer. Which of the sea creatures in example 3 are deeper than the dolphins? So we need to do what to the 1/10? We need to change it to a decimal. I'm making room on my screen real quick. That way I can still use my number line. So how do we... Now remember, we have... Okay, so I'm going to do this guy green. Negative 1/10. Now you can divide 10 into 1, but when it's already here, what do we know?
It's a tenth.
It's a one place value. So you can just convert it to a decimal.
Wouldn't that just be a thing?
Huh?
I was gonna say, if it would be
It is because it's a fraction, so it's not going to be a whole number. If doing this in your head is not concrete, then please do the division so you can see it.
So how did you get to the 1/10?
Because remember, when I'm going from this one, remember how if it's in a decimal and I just put it over how many place values? So going the other way is I'm just reversing it. So let's graph this shark. Where is the shark land? Shark land. Is it in front of or behind the point 18?
18.
Is it closer to the 0 or further away?
Close.
Yeah, it's right here. Oh, I wanted green. Come back, green. So the shark lives right, not the shark, dolphin. Dolphin lives right there. So this is negative 0.1. Dolphin. I'm running out of room to write. There we go. Dolphin. So what's the question? Which of the sea creatures in example 3 are deeper than the dolphin?
All of them. All of them.
All of them. So squid, anglerfish, whale, and shark.
Can we just put all of them?
Is that a 9?
I will let you cheat and put all of the sea creatures.
I did.
If you wrote them, that's fine.
Number 9.
Yeah, this is number 9 on your own. All of the sea creatures.
This is explained.
Thank you.
I don't ever care about explaining. You don't have to write this red part. Unless you're an overachiever, then do it.
One more point.
And whale. Very good.
Dolphin doesn't count.
Nope, because it's everybody below the dolphin.
Poor dolphin.
I know. Okay, you are to do IXL A11. Have at it.